Hi, and welcome to Komsky Corner. Today we're going to be talking about connections, encryption, and layers. This video is specifically for the new OCR GCSE Computer Science course, however, it's applicable for most exam boards. So let's start off by looking at the different modes of connection. We first have wired connections. These come in the form of Ethernet cables, and they allow data to be transferred between devices on a LAN. Wireless connections do pretty much the same thing, but as the name suggests, they do so without wires. Instead, a wireless router provides a connection with the physical network. There are a couple of advantages and disadvantages of wired and wireless connections that you need to know. Wireless connections are cheap and easy to set up, and it is easier to connect and add devices to the network as there is no need for extra hardware. On the other hand, wired connections are difficult and expensive to set up because lots of wire is needed. This makes it difficult to add new nodes to the network, as you may have to rewire the whole network, which can be a pain. However, wired transmissions are much faster and safer than wireless transmissions. This is because interference such as walls can slow down or disrupt wireless transmissions. Also, on a wireless network there are more security threats as the packets of data can be intercepted more easily, making the network more vulnerable to hacking. So you might have heard of the term encryption before. Encryption plays a really key part in keeping your data safe and protected from some of the security threats just mentioned, like hacking. Encryption works by using an algorithm to scramble the data so that it cannot be understood by anyone other than its intended recipient. And what we use to scramble or encrypt the data, as well as to decrypt it and get it back to its original state, is called a key, as you can see in this picture here. There are two types of encryption methods, and the first is called symmetric key encryption. This is where one key is used to do both encrypt and decrypting the data. For example, here we have a Caesar cipher encryption, a common encryption code where the letters of the alphabet are shifted. In this Caesar cipher shift, we can see that the letters have been shifted 3 places to get the encrypted code. As you can see, only the one key, the one that shifts the letter 3 places, is used. Also, it's important to note that the unencrypted string is called the plaintext, and the encrypted string is called the ciphertext. The second type of encryption is called asymmetric encryption, and this is where 2 keys are used, a public key and a private key. The public key is used to encrypt the message, whereas the private key is used to decrypt the message. It is also quite useful to note that these 2 keys are different but complement each other. On the right of the screen, you can see the typical example used to explain asymmetric key encryption, with the fictional characters of Alice and Bob. If Alice is trying to send a message to Bob, she will encrypt the message using Bob's public key that is available and known by everyone. To decrypt this message, Bob uses his own personal private key that only he has access to. Next, you need to be able to know what IP addresses and MAC addresses are. An IP address, or Internet Protocol address, is a unique address for each device on a network, and it is assigned to you when you access the Internet. It identifies and differentiates every device on the Internet. There are 2 types of IP addresses that you need to be aware of, IP version 4 and IP version 6. As I'm sure you can guess, IP version 6 is the later, updated, and more commonly used version of IP addresses nowadays. This is because IP version 6 is a 128-bit hexadecimal address, as opposed to IP version 4's 32-bit number addresses. This means that IP version 6 has more unique addresses that can be made, which is why it's used more often. Now let's briefly look at what MAC addresses are. A MAC address, or Media Access Control Address, is a unique number that identifies the actual device that is connected to a network, and it is hardwired into your actual device when it's manufactured. Next, let's take a look at standards and protocols. Standards are an agreed way of doing things that provides rules within different areas of computing. Some common standards include MP3, HTML, and Unicode. Using standards have many different advantages for programmers. These include the fact that it will be easier to work with other people if you work to the same standard. It will also be easier to make programs that work on different systems. And if the software can work on more systems, it will be more popular as it's more widely compatible. Protocols are standards that govern how networks should function and communicate, and there are many different types of protocols out there, but for your GCSE you only need to know 7, so we are going to go through those now. The first protocol that you need to know is HTTP, which is the Hypertext Transfer Protocol. This is a client-server protocol and it is responsible for requesting and delivering resources. Next, we have HTTPS, or Hypertext Transfer Protocol Secure, and as you can probably guess, this does pretty much the same thing as HTTP, but it is used over secure encrypted connection. FTP is the File Transfer Protocol, and this is the protocol used to share and send computer files over the internet. The next 3 protocols are all to do with sending and receiving emails from an email server. So POP is Post Office Protocol, and it is used by email clients to retrieve emails from a remote email server. IMAP is the Internet Message Access Protocol, and it is basically what has recently replaced POP, as it is another protocol for accessing email messages from a server. So whilst POP and IMAP are used to retrieve emails, SMTP is the Simple Mail Transfer Protocol, and it is used to send or deliver mail onto a mail server. So that's all for the email protocols, and lastly we have TCP/IP, which is the Transmission Control Protocol/Internet Protocol. This is a common protocol used to transmit data between networks. For all these protocols, you just need to be able to know the name, abbreviation, and use for each. You should also be able to identify which one is to be used in a given scenario or situation. To end this video, let's lastly have a quick look at layers. Layers are different sections of a protocol organized in a distinct order. Here you can see some of the different layers in both the OSI model and the TCP/IP stack. You do not need to learn any of these, I've just put them up here so you can visualize layers a bit easier. There are many advantages to using layers, and these include the fact that they can reduce the complexity of the problem by breaking the problem into more manageable chunks. Layers also mean that different people can be working on one part of the problem without needing to modify or affect other parts of the system. For example, in the case of the TCP/IP stack, changes can be made to the application layer without affecting the other 3 layers, which can continue to work as normal. So in this video we have looked at modes of connection, encryption, IP and MAC addresses, standards and protocols, and layers. So if you have enjoyed this video, then please be sure to give it a big thumbs up and subscribe to my channel for more. See you next time! Bye!